This is a demonstration video on the automatic construction of agent-based simulation using business process diagrams and ontology-based models. In this demonstration, we'll introduce how the business user can construct and run an agent-based simulation model using our tool without help of software developers. The common problem in industrial projects is how to organize multifunctional teams to meet a project's targets. Here, we'll construct an agent-based simulation model that captures the behaviors and interactions of multifunctional teams to estimate the time and costs. We assume that a project consists of a set of tasks, each of which is associated with a complexity parameter that determines the level of difficulty in executing the task. Each task is assigned to a team. The technical leader helps team members to learn a new skill or to improve the skill so as to carry out the assigned task. Individual team member has the social technical attributes including capability and motivation. We will start with modeling the agent behaviors using Eclipse BPMN2 modeler. The BPMN model shown here is a collaboration diagram that consists of 5 participants: resource manager, team, task owner, technical leader, and team member. Resource manager is in charge of distributing the next task by sending task dispatch message and receiving task completion message to and from team agents. Upon receipt of task dispatch message, team agent informs task owner agent by sending task arrival message. Then, task owner agent determines whether the task's complexity is higher than team's capability. If it is, then task owner agent will send learning process request message to technical leader agent to initiate the learning process. If not, it will carry out the task by performing, calculate work time, and perform task activities. When technical leader agent receives learning process request message, it asks each of team member to identify which one is a candidate to learn by sending request for learning. It updates the learner list with the response and continues this loop until all team members are asked. Next, it will select the team member to teach and the selected one will be informed by sending selection result message. Then, it will repeat this process until all team members reach the desired level of capability. Next, we'll demonstrate modeling the organizational information that specifies the project and team information using OEM modeler that we have developed. The OEM model represents the organizational information including entities and their relations in a hierarchical manner. Tasks collection node has 4 task entity nodes, each of which has 2 attributes: complexity and status. Task assignment entity node represents which task is assigned to which team. It defines 2 attributes of task assignee. Here, the user can select a value for each attribute using combo box. In Teams Collection node, 2 teams are modeled with 3 children nodes: task owner, technical leader, and team members. Task owner entity node defines some attributes: work time, current task, and team including social technical attributes, capability, availability, allegiance, and motivation. Also, technical leader and team member nodes are similarly defined. In Entity Definition dialog, the user can define commonly used entities as entity type having the specification on the attributes. For example, Task Owner Entity Type defines a set of attributes that we have seen in Task Owner Entity nodes. This is the last part of the demonstration that will show how both models can be used to analyze the effects of different task assignments by one-click simulation run. To change the task assignment for evaluating the scenario, it can be done easily with OEM modeler. In each task assignment entity node, change the value of assignee attribute by simply selecting a value in the combo box. Then, save the model and run the simulation. After the simulation run finishes, we can review the outputs for each agent. As you can see here, Team 1 is assigned to tasks 1 and 4 where the complexity of 2 tasks is same as the capability of Team 1. Therefore, Team 1 does not need to learn. Meanwhile, Team 2 is assigned to tasks 2 and 3 where the complexity of task 3 is higher than the capability of Team 2. Team 2 needs to learn from technical leader to carry out task 3. However, the capability of Team 2 is higher than that of Team 1. Team 2 is more competitive than Team 1 in the total work